Hello! In this episode I have Harman Kardon AVR 235 receiver for repair. This is a 7-channel receiver and something is wrong with it. I am not sure what exactly. I believe there is no output. Let's have a look. I plugged it in. You probably can see this light is on. And it powers up just fine. And the next step would be to connect speakers or headphones, but I want to be careful because I'm not sure what's wrong with this. And I want to at least check if there is no DC on the output, which can burn the speakers or headphones. Here is the back of the unit with a lot of connectors, analog and digital inputs and outputs, and 7 pairs of speaker terminals. So let's grab a multimeter and check for DC. Minus 55 millivolts, 55, 47, 59, 43, 54, and 30. Small DC offset like this is normal, so no problem so far. And here I found a stereo connector to check the headphones output. Here I removed the cap from the connector and attached my probes to one of the channels. And there you go. No DC offset here. And I'll check the other channel as well. And here is the other channel, no problems there. And of course this test is not a guarantee. Just a basic test to avoid the most obvious trouble, and I still would suggest not to connect expensive headphones or speakers, and perhaps even use dummy load power resistors and oscilloscope. Here I am probing the headphones output with my oscilloscope. I switched the unit to AM receiver and the volume is fine. This must make some noise, but I see nothing at all here. And I also tried switching to CD analog input, and I attached this cable to the CD input, and this must make some noise as well when I touch the input connector, and nothing is going on at all. Let's check the preamplifier outputs here. I attached this adapter to my scope, and let's check front left channel. And again I'm using this cable connected to CD input, and this tip is left channel, and as you can see, nothing at all. It's time to have a look inside, so I took the cover off, and someone was in here before me, because this ribbon cable was disconnected. I doubt that the unit is not working because of this. Perhaps this is just an indication that someone tried to troubleshoot it before. I think so, because this board is for video inputs. There are several composite and S-video inputs here. There is still a chance that the power, let's say, might be routed through this board. So I can reconnect and test again, but let's have a look around first. Here we have a massive transformer. On this side is probably power supply board with another section here with the voltage regulators on the heatsink. On the other side probably high voltage power supplies for the power amplifier. This is mains outlets on the back. This, as I said, is video inputs. This board is for analog inputs. This must be FM and AM receiver. And on the bottom we have 7-channel power amplifier board. Here is a fan on this massive heatsink, and all active devices are on this side. And this ribbon cable is running to the front panel board. I found a service manual with full schematics for this unit, but I see on the board next to this connector plus and minus 15 volt power rails are marked. Let's start from checking this. Let's see. I connected the ribbon cable just in case. The receiver is turned on. Here we have ground, and here we should have positive 15 volt rail, and we don't have it. And here we should have negative 15, and it's not there either. Here's our problem. So perhaps we should focus our attention on the power supply, and in particular on this section, which has three, I would think, voltage regulators on this heatsink. Here I found this power supply board in the service manual. This connector is from the transformer board, and this connector is the output to the main board. So we should have pin 2 and pin 4 AC 17.5 volts coming in, going through this bridge rectifier, and after that we have, after some filtering, we have plus and minus 18 volt rails, which go through 7815 and 7915 voltage regulators, providing plus and minus 15 volt rails. So let's check the input and the output. Let's check the voltages on this connector from the transformer board to the power supply board. Here we have a ground point, and I set the multimeter to DC for now. Pin 1 should be 5 volts, no problem here, and pin 8 also should be 5 volts standby, and we have it as well. So now let's switch this thing to AC, and we should see on pin 2 and 4 17.5 volts. This is pin 2, and we see nothing. And here is pin 4, and nothing as well. So now we should check this transformer board. Here is the transformer board, and I believe this section of the transformer provides these two 17.5 volt rails with this center tap going to the ground. Each side goes through a fusible resistor, 0.47 ohms, and we have just a few capacitors for filtering. This side goes to pin 2 and the other side goes to pin 4. So let's check here. So I believe this is the center tap, and this is one side, 17.4, and this is the other side, 17.4. No problem, right on the transformer. And here we have one resistor and another resistor, of course on the other side of the board, and this one goes to pin 2, and here we have nothing. And here on the other side of the resistor there is a trace to pin 4, and we have nothing as well. So it seems to me that these two fusible resistors are blown. So now we have a choice. One approach would be to find some sort of replacement, replace them and see if the receiver would work. But they can blow again if there is some other fault somewhere which results in excessive current draw on these two rails, plus minus 15 volt rails. And we could try driving these two rails from a current limited lab supply, for example, to check for that, and only after successful check worry about replacement resistors. Let me think about this. And going back to the schematic, I see that besides this rectifier providing plus minus 18 volt rails, there is also this rectifier providing this rail marked PU and going to pin 7. So if we provided plus minus 15 volt rails from a lab supply, this rail would be missing. And we can provide this one too, but the setup gets even trickier. And besides, this board is quite hard to reach. If I wanted to solder wires on the back of the board or to this connector, this is a bit difficult to do. So I'm not sure this is the best way to proceed. Here I found these two resistors in the list of components, R104 and 105. You see, resistor and fuse, 0.47 ohm, 1 watt, and J means 5% tolerance. I found a couple of 0.33 ohm resistors of the same size. This is the closest match I have right now. And I hope this should be okay for a test. And by the way, look how these resistors are standing above the board. This is intentional. Longer legs work as heat sinks to some extent. Unfortunately, these have slightly shorter legs, but they have lower resistance as well, so they won't heat up as much. Alright, I replaced the resistors, so let's turn this thing on and see if they blow again. Oops, and they did. I saw some smoke. Look at this. I'm not sure you can see it very well on camera, but this capacitor has a burn mark on it right here at the top. And this is the one which is right across these two AC lines. Here it is. Now you should be able to see the burn mark. Check this out. My LCR meter is going crazy with a negative value. And that means our device under test is not a capacitor anymore. Let's switch to resistance. And sure enough, we have a dead short, about 9 milliohms. Here I found a replacement capacitor, no problem at all, 104 nanofarads. I'm checking the resistors. And it seems to me that one of them has died. This is the one on top, and it seems to be open. The second one here seems okay. 0.7, that's because of some offset in the meter. Let's look at the schematic again, just to clarify what happened. This capacitor was shorted, So we had a short circuit right across this section of the transformer, and this time one of the resistors failed and the other one survived. I managed to find one more 0.33 ohm resistor. Let's put this one in. I replaced the resistor. Let's check now. This is the center tap, which is ground, and this is one side, and this is the other side. And now it looks right. Now let's check the DC rails after the regulators. Here is my ground, and here we should have positive 15, and we only have 9 volts. And here we should have negative 15, and we have minus 10 and a half. This does not look right. I disconnected this ribbon cable, and now 15 volt rails are fine. And I also noticed that these two resistors were running hot before, and now they are not even warm with this disconnected. So it seems to me that there is some other fault on this board, and that's why probably this was disconnected before. Someone figured this out and didn't care about the video inputs, and perhaps unit worked fine. So let's check. Here I am probing the headphones output again, and I'm touching the CD input, and there you go, we have something. Here I attached this old single speaker I have for testing purposes, and I don't want to play any copyrighted music. That's why I attached this Korg rhythm synthesizer instead. No problem, we have our output. So now let's see if I can figure out what's wrong with that video input board. After some poking around and looking at the schematics, I believe that there is nothing wrong here at all, except that this marking on the board, plus and minus 15 volt rails, is misleading. This board indeed has two rails, plus and minus 15 volts, and these two resistors are here to pass these two rails to the video board, and on the schematic the input here is marked plus and minus 8 volts. And these two rails go directly to these two voltage regulators, and this one is 7805 and this one is 7905, so they provide plus and minus 5 volt rails. And these resistors are used just to drop a few volts before these regulators, so they don't have to drop all 10 volts on them. Here is the schematic for the audio input board, and here we have these two resistors from plus and minus 15 volt rails going directly to the video board connector. On the positive side we have 15 ohm 2 watt resistor, and on the negative side 33 ohm resistor. And in fact in this unit I see that on the positive side 27 ohm resistor is populated instead. Let's do a little sanity check. On this 27 ohm resistor we have about 4.6 volts drop, and we divide 4.6 by 27, and that means about 170 milliamps. And if we multiply this by 4.6, this means about 0.8 watts. which is not too bad. Yes, they are running hot, but these are 2-watt resistors. It's not a problem. And to check that the video board is working, I connected this composite monitor output to my monitor, and when I'm making selections here, this info also appears on the monitor. I don't really like the idea of leaving these 0.33 ohm resistors in place instead of 0.47. First of all, they have lower value, and that means they can handle more current before they blow, and that means less protection. And the second reason is that I replaced the one which failed, but the other one also experienced this current shock and might be damaged to some extent and can potentially fail at any moment. So I shopped around, and in a local electronics store I found these 0.51 ohm resistors, also 1 watt, 5%, and they are marked RSF1B, and I found the datasheet for them, and they are flame-proof resistors. Unfortunately, the datasheet does not explicitly say they are fusible resistors, and I'm not entirely sure this is the same thing. I think that fusible means some extra guarantees about the time it takes to blow and such, but I believe this should be good enough. And 0.51 instead of 0.47 means 51 divided by 47, about 8.5% higher value. And the original resistors have 5% tolerance, so this should be good enough. The actual value is about 0.5 ohms, and this meter should be around 1% accurate in this range. And let's check the second one. About the same. Perfect. The receiver is back together. Job done. Thanks for watching. And don't forget to subscribe to see more repairs and other projects. Bye!